Hey y'all, today we're going to look at how to measure experimental data, and we're going to look at some of the different measurements we can make with regard to experimental data, things like yield and error calculations. So let's go ahead and get started. Experimental data in AP chemistry is going to be largely quantitative. You're going to get numbers, values that represent measurements which are taken over the course of processes, chemical reactions, or data collection of some kind, therefore. You need to be able to take that data, look at the data, and analyze the data. So the first thing you need to be able to look at is exactly what data are you collecting? What units are there? What does the data represent? Experimental data is going to be everywhere in AP chemistry. As we're doing labs, as we're doing problems, you're going to see data everywhere. And it's really important to understand where that data comes from, because you're going to be then using that data to perform different calculations. You're going to have a formula sheet on the exam, and that's going to provide you with all these different formula to use as you're going through the year. So what needs to happen is you need to be able to look at the data in front of you, figure out what it is, and then figure out how to use it. The other thing is, data isn't always perfect. In our classes, in our labs, there will be error. We need to be able to look at that data, say, is it what we would expect it to be? And if it's not, where is the error from? We can use information from the lab to be able to then predict why our data wasn't what we expected it to be. We use the calculations for percent yield and percent error to be able to quantify the error that we're seeing. The first calculation that we're going to look at is called percent yield. In order to know the percent yield, you need to know the theoretical yield. The theoretical yield of an experiment is how much of the product you expected to make. One way you can think about percent yield is the efficiency of your chemical reaction. If your reaction is perfectly efficient, then you're going to convert every single thing as a reactant into your product, right? So in theory, a perfect process would have 100% yield. But believe it or not, we're not going to be perfect here. Perfection is impossible in AP chemistry. It's impossible in life. So we are going to see percent yields that aren't 100%. So let's figure out how to calculate it when we inevitably are going to fall short of that perfection. In order to calculate percent yield, we need to know two things. Your actual yield, sometimes known as the experimental yield or the observed yield, and the theoretical yield, how much you expected to make if everything had gone perfectly. The way we calculate percent yield is by taking the actual or observed or experimental yield, and we divide it by the theoretical. We then multiply it by 100. That's going to give me my percent yield. The second equation is percent error. There's actually a lot of times students getting confused between these two equations because they use the same variables and they kind of look similar. But let me remind you why percent yield is different than percent error. Percent yield is a percentage that can only be positive, right? You're basing this off of 100%. So you can either be above 100% or less than 100%, but you can't be negative. Percent error, however, has a direction. It can be negative, it can be positive, and that matters. So let's talk about how to calculate it. With percent error, we take our actual observed data, our yield that we see, we subtract the theoretical yield from that, we divide that by the theoretical yield, and then we take that number and we multiply it by 100. That's percent error. Now, think about it this way. If your percent error is negative, it's because your actual yield, your experimental yield, is less than your theoretical. If your percent error is positive, it's because your actual or experimental yield is greater than your theoretical yield. So percent error gives us a direction. And that's a really important tool as well. To know the direction tells us a little bit about the possible source of error. So let's apply this to something that's not chemistry, a real world example. Let's say I'm playing catch with a friend. When I'm playing catch with a friend, I want to throw the ball to my friend who's 10 feet away, but I throw it 15 feet. What would my percent error be? Well, take a look. The actual value that we threw it was 15 feet. The theoretical, the expected, what we should have thrown it was 10 feet. So we take the 15 and we subtracted the 10. Then we divide it by that theoretical. We should have thrown it 10 feet, so we divide it by 10. So it's 5 over 10. That's 50% after you've multiplied it by 100. So we had a percent error of 50% in that situation. It's a positive 50% because of the fact that I overthrew it. I threw it further than my friend was standing away from me. Now that we've done a real world example, let's go to chemistry. Pablo here did a chemical experiment. In this chemical experiment, he was collecting a solid mass of this chemical precipitate that was forming. When he did this experiment, he expected to obtain 19.7 grams of the product, but he only got 12.0 grams of the product. So he didn't get what he expected. There's going to be error. So take a second and calculate what Pablo's percent error was. Also, tell me what Pablo's percent yield was. All right, take a second and solve for both percent yield and percent error. You know what, let's start with percent yield. A little bit easier to find percent yield. What we're going to do with percent yield is take the 12 grams that Pablo found, divide it by the 19.07 grams that we expected to find, multiply by 100, and our answer is 60.9%. So Pablo had a percent yield of 60.9%. What about his percent error? Now, percent error, we're going to take that 12 grams that he collected, subtract the 19.07 grams we expected to collect, divide by 19.07 grams, multiply that whole thing by 100, and we end up with a percent error of negative 39.1%. So Pablo's error was 39.1% less than we expected to get. So we've now used percent yield and percent error to provide an understanding of what Pablo got versus what he expected to get. Throughout the year, you're going to be calculating percent yields and percent errors. But more importantly, you're going to be interpreting what they mean. So now that you know how to calculate them, going forward, it's going to be really, really important that you then take that information and apply it to what you did throughout the course of the experiment to figure out what might have gone wrong. There are certain errors that you might create, positive or negative percent error, depending on which ones occur. So that wraps up this video and your summer work unit. Today, we learned about how to calculate percent yield and percent error and why it's important to be able to do those calculations in AP Chemistry. Over the course of this entire unit, you have hopefully gotten a foundation of understanding of everything from the ideas behind chemistry, the periodic table, atoms, periodic table trends, and now a few laboratory experimental techniques. And in doing so, I hope you are better prepared to start this journey of AP Chemistry. You will walk in on the first day prepared if you were able to watch these videos and if you've done the work you needed to do to prepare for our test within the first day or two in class. I look forward to seeing you in class. I'd like to thank Colin Belcher and Owen Zhang for writing, filming, and editing this video. I'd like to thank you guys for watching this video and the rest of them this unit. Look forward to seeing you in the fall. Have a great one.